Okay, so I made a simple Tetris game in assembly language for 64-bit Linux. So let's build it and see how it works. Okay, so you can see that we assemble it with the NASM assembler and then link it with GCC. So let's run it. And there we go, we have Tetris. Whoops. So you can see you can move the blocks around and we can rotate them. So this is clockwise, counterclockwise, and then you can press space to do a soft drop, which just makes them fall down faster. And it uses the classic rules for rotation. So right now I'm trying to rotate the eyepiece, but it won't let me, and that's because there's no wall kicks or anything like that, so I can't rotate this either. And it's just because the classic rules are a lot simpler to program, and they're less tedious because there's just less cases that you have to deal with. But yeah, we have Tetris. You can place down blocks. I'll show you clearing in just a moment. There you go, you can clear it. And you have a score, and your score gets like updated as the game keeps going, but it only gets output when the game finishes. The way I did it is like you can have text if you want on the window, but it's kind of tedious to program, so I didn't bother doing it and just have it output to the console. So anyway, yeah, that's how this works, and the game is finished right now, and so you get your score. So I got 1100, and if you want to play again, you can press space, and it will start the game again. And yeah, you can just keep doing that, and then if you ever want to quit, you can just press escape to quit. So the way I handled graphics was with a really low-level graphics library called xlib. And basically xlib lets you communicate directly with the X server on Linux, which is the windowing system on Linux. And this isn't typically how you would do something like this. Like if you were making a game with graphics, you would probably use a higher level graphics library like GTK or Qt or something like that. And you would use them because they sort of provide more powerful tools, and they sort of abstract away the complicated windowing stuff. But I figured that I might as well just, since I'm doing it in Linux anyway, I might as well just use the low-level library and learn how Linux windowing works under the hood, and it was pretty interesting. So this is the assembly file. It's all the whole game is in just one assembly file. This is the start. It's pretty long. It's like, I think, 1500 lines of code. So these are all the xlib functions that you need to call to, like, open the display and get color values and set all the things you need. This is just reserving some structs. There's no structs in assembly, but you can, reserve a bit of space, and then if you know what the offsets of the members are, then you can sort of simulate structs that way, and then there's a bit of data here. And yeah, this is the main part of the code, so let me make it smaller. So yeah, you can see it's pretty long, and that's just because, you can't do like complex arithmetic or anything like that on a single line. And it's just like a more tedious way of doing it in a high-level language like C. If we go to main, for example, so this line creates a window, but it would be like one line in C, but in assembly it is, quite a lot of lines, because you have to manage you have to get the right data in the right registers, and you have to make sure the stack is aligned and has the right values on it. So it's a bit more tedious, but it's honestly not that bad. Once you kind of get used to it, it's relatively simple. The hard part wasn't calling like the xlib functions, which I thought was going to be the hard part, because xlib isn't really designed to be called with assembly functions. You're really supposed to use it with C or something like that. But the hard part was like the the complex arithmetic that I had to do. So for example, in the rotate function, this is the function that rotates, tetrominoes, and you can do to do it, you need, like, at least the way I did it is with linear algebra, and you have like a rotation matrix that you multiply with your local values of the Tetris tiles, and like you can do it, but it is kind of complicated, and it gets a little bit messy with the all the registers and what values are in what registers. It does get kind of complicated, but again, once you get used to it, it's not so bad. I tried to sort of keep the complexity down by doing branchless programming where I could, with like conditional moves and stuff, but I'm not really good at that yet, so I wasn't always able to get that to work well, and so there's still a few places where I definitely have a bit of spaghetti code. But anyway, yeah, this is pretty much it. If you'd like to, try the game out for yourselves, or just see the source code or whatever, I'll leave a link to my GitHub where you can find the source code in the description. Yeah, I think that's pretty much it. Thanks for watching.